This is our free response question on our pre-exam number 3. And what we have is they gave us these two cylinders that are attached to each other. We have a mass 1 at the small radius, and we have a mass hanging from the larger radius. And they want to know, what is this mass going to be needed to be to keep this 20 kilograms from forcing it to rotate? So again, what we have is here, and we've seen this problem several times. We have a larger radius, a smaller radius, and you know if we had just a mass hanging on the blue one, the larger one, it would want to rotate clockwise. If I had one hanging here on the outside of the smaller one, it would want to rotate counterclockwise. So what we want to know is what mass will cause equilibrium, which means no spinning, to make it stay just stationary like this. So we have this torque on the outside, and it's a larger radius, and we know if the circle got bigger and bigger and bigger, it would have more and more torque because that mass would be farther away from the center. I think this problem is a little easier to solve when I wrote it so you would see this from a side view, where I can see I have this mass here, the first one, 20 kilograms, and I want to know this one to make this not rotate back and forth. So that means we have equilibrium, not spinning, so the net torque on the whole system is equal to 0. Other things I know is going clockwise we count as negative, counterclockwise is positive. That's our right hand rule, my thumb going up like this. So when I write the two torques, I have torque 1, which is clockwise, minus torque 2, wanting to go clockwise, is equal to 0. I know torque is equal to the amount of mass I have on it times the radius, and I want it to be a force, so I also have to take that mass times gravity. Now, and this is what I want to know, this is my unknown, this is my mass 2, that's what I'm looking for. I rewrite the equation, solving for mass 2. Now I can plug in my variables, and it's 7 kilograms. Now I can check to see, is that 7 kilograms reasonable? Well, if I go back up here, this is 20, it's on the smaller radius. To make equilibrium happen, and this is going to have a larger torque because it's a larger radius, I do not need as much mass here to equal out the shorter radius with the smaller torque. So if this is 20, 7 does seem reasonable because I don't need as much mass.